Hello everyone. So our next topic is system programs. Okay. So what are system programs means basically? So it's nothing but it's a collection of programs. Okay. So we can say group of programs of collection of programs that they provide us options to use our programs and environment like development and execution. Provide convenient environment for us to provide convenient environment convenient environment for program development and also the execution of the developed program, okay, other than OS. Okay, so that are called as system programs, or sometimes they are also called as system utilities. Okay, system programs also sometimes called as system utilities. Okay, so this system programs is majorly classified into five types, okay, or you can say five categories of system programs are there. Okay, there are five categories. So what are they? We'll see them quickly. Okay, so first one is file management. Okay, so already we know there are different type of file management means like we'll have a programs to create a file, delete a file, print the list of the file. Okay, again we want to manipulate like create a directory, all this one. So directories, we create folders, no, that is directories for everything is there. So that is first type of system programs, file management. Then again we know second one is status information. So there are programs and functions that is automatically in our system, will tell the date and time. So they are status information, that is second type. Okay, then comes third one. Okay, that is file modification. Okay, for example, we click on the system, so it'll delete the file, create the file. Okay, that file modification. Then programming language support. The fourth one is programming language support. Programming language support means we'll have compiler, linker, loaders that run the programs and execute for us. Okay, so they are programming language support. Okay, and last one is communication. Okay, so last one is communication. So these are the five categories of system programs. We have predefined programs for each one of them, so they'll allow us to access and execute it. Okay, yeah, so these are the system programs. Now we'll see the next topic. Okay, that is OS design and implementation. How we are going to design and implement the OS. Okay, that is design and implementation of OS. Okay, so in design and implementation of things, first we want to bother about the design goals. Okay, whenever we're explaining about design and implementation, first we bother about the design goals, then we bother about the mechanism. Okay, so mechanism and policies. Third part is the real implementation. Okay, so we'll see how exactly each one will contribute in the part of OS. Okay, so first one is design goal. Okay, so what is design goal means? The first problem whenever we are designing OS, we want to define some goals and specification, what exactly it will do. Okay, and again whenever we are designing the OS, so as we already know that the OS will be considering as a two perspective. One is user perspective and one is system perspective, that is nothing but kernel. So we should bother about the user goals as a OS, what are the things it should give for the user as an option, and what is the support it can give for the kernel, that are called as system goals. Okay, so user goals are nothing but basic user requirement. So what are the requirements the user the OS is going to give, and for the system it is system requirement, whatever the system require, so that system requirements to be considered in the system goal. Okay, for example whenever you say user goals, you can say like how easy, safe, secured, how the options easily accessible by the user, and how reliable, how the user can use the OS so that he can learn the basic features and work on that OS. So that comes under the user goal. Then system code is like whenever we write as a developer perspective, okay, who design the OS, they want to make it like easy of implementation, flexible, that should be error free. Okay, it should be very efficient and it should not use more much of memory of the system whenever we implementing. And how it going to schedule all these things comes under system goal, that is system requirement. Okay, so second part of this one is mechanism and policy. Once we decide our goals and requirements and condition, we should follow the two things, one is mechanism and one is policy. Okay, so what is policies means what to be done. Okay, policy means what to do. Okay, so we can say what is to be done. Okay, what is to be done. And mechanism means how to do it, how is to be done. Okay, what to do, how to do, we can say in a short form. So policies means what to do, mechanism means how to do. Okay, so for example, if they say, we'll take one small example just for understanding purpose. You are going to design a timer. Okay, you're going to design a timer, so the timer will have a or you can say counter timer or timer counter. So whenever you're designing the timer counter and decrement counter, okay, we are going to implement that one. So how it will be, it will counter and decrementing counter. So counter and decrementing counter is the mechanism we are going to implement. Getting it? If they say counter means we'll say incremental counter and decremental counter. Okay. Yeah. Then policy. What is policy? Means how much long or how much long time. Okay. How long time it has to be set. So that is done by the policy. Getting it? No, we are going to implement a timer. So the timer have two parts: counter, incremental counter or decremental counter. So these are the parts of the timer. So that is mechanism, what it's to do. So what is the policy means how long it should run. Okay, so how long this timer have a capacity, how much time it can run. All this condition is kept by the policies. Okay. Yeah. Then comes the third part after mechanism and policies. The third one is implementation. Okay, so implementation means we want to bother how we are going to write a implementation. Okay, so usually the operating systems are written in the assembly level language. Okay, we use assembly language. Okay, other than that we can use C program or C++. Okay, even whenever we are using a CC program, so there are some codes called as critical sessions, some complicated codes. So that critical session codes are written as a using assembly itself, even though the major part is written by the CNC program. So them critical part part of this one ways is used, means created using a ASM, and that is assembly code. Okay, and what is the advantage if you use high level language like C, C++ compared to the assembly level? Means whenever we use high level languages, so whenever we are creating, it will become more faster for implementing and using it. Okay, more faster and easy to access, and if it's efficient. Okay, and it is easy to port from one system if you want to transfer to the other system. Also easy. Again, like understanding and debugging also become easier. Understanding and debugging is also become easier whenever we use higher level language. So that's why we use high level languages. Okay, so these are the system design and implementation of a operating system. So thank you for watching. Like and subscribe for more such videos.